Hello, this is the lab makeup for Unit 4, Conductivity Tests. Ionic compounds are formed when oppositely charged particles attract one another. A good example of an ionic compound is sodium chloride. When sodium metal and chlorine react, the sodium atom gives its one valence electron to the chlorine atom to make the chloride ion. The sodium cations and the chloride anions attract one another. These form a lattice of sodium and chloride ions together when in solid form. In this activity, we will observe several properties of ionic compounds and compare with covalent compounds and make some generalizations. Data. Use a small-scale lab approach. Add only 3 drops and no more of each solution in the space on the cover sheet. Touch the conductivity meter leads on opposite sides of the drop. Assign conductivity to categories: none, weak, strong. Note, clean the meter leads between measurements. Also, take care not to touch the conductivity leads together. A little bit of an edit to that. We do have laid out here on this small scale sheet the various solutions that we're using, and they do match the order that's presented in the data table. So distilled water, 10% glycerol, aluminum foil, and the unknown substance. And on the right side of your table, you have 4% NaCl solution, 4% sugar, and solid NaCl. Each, and not in drops, but in various sample cups to facilitate the ease of this video. We won't be needing to clean conductivity meters as we have a set of conductivity meters to save some time within the creation of this video.
Okay, so all we're going to do with the conductivity meter, just a little quick overview of what this is. You got a 9-volt battery. 9-volt battery. You have 2 copper metal leads here at the end, and you have an on and off switch. What we're looking for is the completion of a circuit. A circuit is when you have electrons that are moving in a circle. That's electricity. So what will happen here is that we'll have an outflow of electrons from one lead, and it'll flow back into the other lead and go up to the light and turn it on if the circuit completes. But you have to have ions moving in solution in order for that to happen. So that's what we're looking for, that conductivity, that light's going to come up. So the first thing we're going to test here is going to be the distilled water. On your data table, you're going to indicate whether or not the light that comes on is strong, weak, or none. So this first test is for distilled water. Okay. Second test here, this is for the 10% glycerol. Third test, we have just a piece of regular old household aluminum foil.
Notice there the difference between the previous 2 brightness levels and this one here.
And also think about the type of bond that we're talking about when we have aluminum foil versus the other 2, and how that might affect that. Now our unknown sample. You can do these in any order, it doesn't really matter. And again. Now we're testing 4% sodium chloride solution. And again, make note of the difference in the intensity and the brightness. Next we're doing 4% sugar solution. Okay. And finally we're going to test solid sodium chloride in its dry form. Okay. And that's it.